Let us now discuss how to shift graphs. It will be best if we can start off with the well-known graph. Let's take the straight line. So we'll work out the principles of how the graph shifts, and then you can figure out how the other graphs, the more complicated graphs like the hyperbola and the parabola, also shift. So let's take a straight line, for example. Well, we know straight lines have a general form mx plus c. But let's just take, for the purpose of our discussion, let's take y equals to, say, x, or say 2x plus 3. Fine, so this graph, it can be drawn like this, 2x plus 3. It has the x-intercept, which is when y equals to 0, x equals to minus 3 over 2, and a y-intercept of 3, that is when x is 0. So if we join these two dots, that gives us the line y equals to 2x plus 3. Now, what happens if we consider the graph y equals to 2 of, let's say, x plus 3 plus 3? What is the impact of having x plus 3 here compared to having x there? You see? Now we find that the x-intercept, this time if you work out the x-intercept, you'll find it becomes, well, the function, so we put y equal to 0, so we get 2 into x plus 3 plus 3. In other words, minus 3 is equal to 2x plus 6. So 2x equals to minus 9. Therefore, x is minus 4.5. Okay? So initially, the x-intercept was, sorry, that should have been a minus 1.5. Now it shifts to the point minus 4.5. So you can see what has happened here. We can see that the x-intercept has changed from here. It has moved how many units to the left? Exactly 3 units to the left. So what this tells us is that the fact that we've got x plus 3 here now, the x plus 3, when you change the x into x plus 3, when x becomes x plus 3, the graph undergoes a shift that is 3 units to the left. You would expect it to move to the right because you see a plus 3 there. However, in actual fact, it moves to the left. So keep this in mind. It's a general principle. If the x value becomes x plus something, the graph moves to the left. Likewise, you can experiment and check that if you have, say you have y equals to 2 of x minus 2 plus 3. This time the x-intercept becomes 2x minus 4 equals to minus 3. That's 2x equals to 1. X equals to half. So it moves to half. Now what is the distance from minus 1.5 up to half? You can see the total distance there is exactly 2 units. So what is the moral of the story? It means that the function has moved from minus 1.5 all the way up to plus 1.5, a distance of 2 units. So in other words, because we have a minus 2 here, we can say the graph has moved 2 units to the right. So when you have a minus 2, it moves 2 units to the right. It's easy to check that if you add numbers to the y value, we won't discuss this in detail, but if you have, say, y equals to 2x plus 3, and suppose you add 5 to it, this time it's like adding to the y value. In this case, you'll find that the graph moves 5 units up. That's easy to understand, you see. And if you have, say, 2x plus 3 minus, say, 4, this time it moves 4 units down. Now, this is the general way in which all graphs behave. So, for example, if you have the function, let's take the parabola, y equals to x squared plus 2, and you consider the parabola A, y equals to x minus 1 squared plus 2. See, the original parabola x squared plus 2 is like this. Okay, it crosses through 2 there. That's the original parabola. But if you have x minus 1 all squared plus 2, the graph will go 1 unit to the right. So that means instead of turning at 0, 2, the graph will now turn there at the point 1, 2. It moves 1 unit to the right. On the other hand, if you have y equals to x plus 3 squared plus 2, this time the plus 3 here means it moves 3 units to the left. 3 units to the left. So the function will then occur on the other side, 3 units to the left, so at minus 3. You'll find that the turning point there will be minus 3, 2. Right? Now how about the behavior in the case of hyperbole? Well, let's take an example of hyperbole. Hyperbola. So if we have the function, say, y equals to 6 over x, this function has got the shape of a normal hyperbola like this. It has asymptotes, which are the x and y axes, and also it has axes of symmetry, y equals to plus x and y equals to minus x. These are axes of symmetry. Now let's consider what happens when you have a shift. Suppose you take a, y equals to 6 over x plus 2. So as we can see now, we have the x value becoming x plus 2. What this means is that the graph will shift 2 units to the left. So the entire system will now go 2 units to the left. It's like having the whole y-axis moved 2 units to the left to the point minus 2. That means the entire graph will now be drawn like this. So you'll have a graph like this and a piece like this. Everything is moved 2 units to the left, and we find now that the new asymptotes, let me use a nice dark color, asymptotes are now the x-axis as usual, because that didn't change. But now we find the asymptotes also the line x equals to minus 2. X equals to minus 2. It is now shifted there. On the other hand, if you have the graph y equals to, say, 6 over x minus 3, this time you'll find that the asymptote will now change to the position x equals to 3. Right? If we had to go a step further, and if we had to take, let's say, c, y equals to 6 over x minus 3 plus 5, this time the whole graph moves 5 units up. So the asymptotes will now be at the point x equals to 3, at the line x equals to 3, and also, since the whole thing has moved up 5 units, it'll also have asymptotes at y equals to 5. So this is how shifting of graphs may be handled.